Hello, hello. This is part one of my door build. This is a door between my shop and my garage. It's completely made of Baltic birch. And I get a lot of DMs on IG asking about the magnetic locking mechanism or deadbolt. It's quite simple, so stick around. Let me show you how I made it. Well, you've probably noticed that this is in portrait mode or portrait format rather than landscape. I apologize for that. It's older footage. But anyway, I started with this block of wood. I believe this is some Baltic birch, and I cut a series of slots in it. I believe I used a domino for the slots that are in line, and then I cut these other slots here with the router, and this will provide a space for a bearing with an axle. This will make more sense in a couple of videos. Actually, it'll make more sense right now. So these are like large router bit bearings, maybe a 5/8 or 16 millimeter with a brass axle. I realized as I was editing this is just my test sample piece. So what I've got here is an ordinary scribe. This is, used for trim work, cabinets, countertop installation, whatever. But in the shop, it's a really underutilized and overlooked tool. So I've got this piece of plywood. It's about 1 5/16 wide. I want to put a mark right down the center of that. And so what I can do is just get down here and I'll just eyeball this close like that. Check it from this side. And I'm really close. Even if it made two lines, they'd be really close to each other and you could utilize that. Okay, so I got all my 6 millimeter slots cut for the bearing, right? And then I need to make one that goes across, similar to this, for the brass rod to hold the bearing. And everything's set up except the depth is not quite right. This depth, I am limited on this to the depth stop with these 5 millimeter increments. Not quite right for me. Super easy solution. This is some irrigation risers, sprinkler risers for your lawn. I just cut a piece, right? Modified it slightly to look like that, so that this dude will just snap on and off like that. And I can make these any length I want. And that goes up in there. Yeah, super easy solution. Those work the best. And I loved seeing this. Look at that old Domino Dock prototype. Okay, so I had made this some time back. It's just plywood. So I'll clamp that dude right there. Then I can take my XL. It holds it in there nicely, right? Of course, this is the original rendition of the Domino Dock. This thing has taken over my life. And now I have Domino Docks for the DF500 and for this larger machine. And with that, I can cut all these slots. I'll leave a link to my website in the description, yeah? Just want to do a test cut. I'm going to have a series of these. And they're going to be going on this rod. There's going to be 9 of them. And this will allow, oops, there goes my bearing. This will allow this piece of metal or deadbolt to glide across there. I'll show you what I'm doing in a future post. So I got some magnets in from K&J Magnets, and I love projects involving magnets, right? And I have this sliding deadbolt, solid steel. There's aluminum on this left end. And I've drilled this hole. It's a 1/2 inch hole. And with that, I will slip in this 7/8 long magnet. It's 1/2 inch diameter, 7/8 long. Let me grab one of these guys, and bam! Oops! And that'll slip right in there. Check that out. Beautiful, perfect fit. And I get a lot of questions about rare earth or neodymium magnets and how long they'll last or if they'll lose their strength. It's very little that they'll lose, 1% over 10 years, so not much at all. So now, once that thing's in the door, I'll have another magnet, and it'll either oppose or attract to operate this deadbolt. It's going to be beautiful. So I'm working on my door jamb, and I've cut these domino slots in the edge in 5 places. And let me set this camera. I'll show you why I'm doing that. So I've got these magnets, and these are pretty substantial. They're like 5/8 round by 3/16 thick. Yeah, one guy will go in there like that. And then another one will go in this maple. This is going to be part of the door edge. This will get veneer covering that so it doesn't show. And then this will help keep the door closed. Like so. All right, so I just made a simple jig to route those holes with the domino. And this jamb is pretty substantial. It's 7 inches wide, 8/4 poplar, and of course it's all primed both sides before I installed it. Of course it has corresponding magnets in the door, and this was a little bit of an afterthought. Since it's not going to be a doorknob, I wanted a way to keep that door closed, kind of like a refrigerator door. So, and it's a pretty substantial door. It's pretty heavy, so I needed plenty of magnets, but I believe this will do the trick. Did I mention the word substantial? So these two pieces of poplar, they've been ripped on a straight line saw, and they're dead coplanar to each other. And then these pieces of aluminum, I've put those parallel to each other and also checked for coplanar by siding them from this adjacent side exactly the same way. And now we have a perfectly flat platform, not necessarily level. I don't care about level. I just want it flat, dead flat. And now I'll put some intermediate guys in between here, and then my substrate will go on top, and I should have a nice flat platform, yeah? So this was a few years ago, and now I have a 5-foot by 8-foot rolling island set up, and I can do all kinds of layups. So this is an even better solution. I have these long pieces of aluminum, and I put white tape right here and black tape on the one in the back. See that? This one isn't hard to show, but it's right there. So I just put white tape. I used a razor knife to cut it off straight off the top. And then with the white wall as a backdrop, I can get down here and sight that. And when that tiny little sliver of black goes away, I know that those two pieces of aluminum are coplanar and flat. It's interesting, watching this older footage makes me feel blessed because I now have a slider where I could have done this, but this crosscut sled worked great. And so essentially what I'm doing here is I'm cutting several of these pieces of frame material at a time, and these are the vertical uprights for the torsion box that I'm going to build. And that push block just holds everything in place. It keeps everything nice and accurate as I make these crosscut dados. Bit of a side note and a quick tip: if you ever drop your arbor nut, just grab a magnet, put it at the end of your tape, and voila. All right, so I've got all the dados cut, my vertical pieces. This is for that torsion box that I'm making. I want to do the same in these horizontal ones. Incidentally, when I use my sled on my table saw, I just put some 1/4 inch down to provide a zero clearance. This slot's going to get chewed up no matter what you do, so that works good for me. And there's some benefits. I'll show you what I mean. I've got these marks lined up where I want those dados, and I can put this first mark lined up with that slot. I can bring this spacer right there, lined up with the other one, and then when I put this guy down, I just have to put it right against that. So it's super simple and accurate. Now I'll cut my first dado, drop it right over that indexing board, and make all my cuts all the way down both sides. In actuality, I would cut the dado first and then screw that little spacer down. Okay, there it is. Check it out. So this grid work or framework, inherently, in and of itself, it's not very strong. You can see it moving around, it flexes a little bit. But once I put a 1/4 inch skin on each side, and with glue, stick this in my vacuum bag, it's going to come out rigid, strong, and lightweight. So yeah, exciting. All right, this mechanism or sliding bolt, you know, belt sanders aren't just for wood. We can use them on metal as well. And I believe I lacquered this, and to this day it still looks beautiful and no rust. Here we go. Beautiful, flat, strong, lightweight torsion box. Now, of course, when I made the torsion box frame, I made accommodations for the sliding bolt mechanism assembly that will slip into place right here. All right, a little bit more work at the bearing block assembly, and I believe the interior dimension of the router bit bearings was 4mm, so I took some 3/16 brass, turned it down at my lathe to make it 4mm, so I would make a nice snug axle.
Okay, there's the brass axles, I guess you'd call them, in place on the bearing. Super nice fit, really tight. I had to slightly press them in place. And this dude looks like that, and so that'll get pressed into there. I'll put a little bit of epoxy right here on the edges just to hold that in place, and should create a nice rolling platform.
All right, here's another couple of shots of the rolling platform, or bearing block as I started to call it. And this could have been made in a number of ways, but I'm proud to say that after a few years, this thing still works perfectly. All right, you can see the little roller assemblies down inside there. I'm making good progress on this thing. Get the deadbolt, we'll slip that in place. And the reason I used aluminum on one end, well, if I just tried to use a magnet on the steel, it's just going to slide. It's not going to do anything. It would actually pull this bar back as it gets to the end of its, well, even then, it just doesn't work very well. So that's why I chose to use aluminum. That way I'm not worrying about magnetism, except exactly where I want it, which is right there. And it'll slide back and forth, or oppose. This thing has to be really smooth, right? I don't really get a second chance to adjust things, so. And I might put a magnet on the end here to keep it from bouncing. Finally, the last trial and error. This is what I came up with. Initially, I had this magnet in here flush on both sides. I ended up adding another 1/2" magnet, so it sticks out on both sides, a little bit more attraction, and I had to cut a small dado to allow this to go inside like so, and this will end up getting a cap, and then this whole assembly will go in between the rest of the door. This clip just shows a small magnet that I put at the end of the deadbolt to keep it in the unlock position. That way it doesn't fling open and slam on the outside of the jamb. Hello. So I just wanted to show you, using a router for jigs like this and making templates doesn't have to be complicated. Check it out. So I have 2 pieces of 1/4 inch. I needed to make this cavity with a 1/16 of an inch deep cut, and then this through slot. And just keeping it simple, I just made these spacers, 1 jig, and by using this turret, I can easily set the plunge rod depth. So the first cut went all the way through. Then I move all these out of the way, set the turret again to cut a 1/16 of an inch deep right here, and made the rest of that cavity cut. So yeah, just keep it simple. From start to finish, this took me under 15 minutes to make both of these, including the jig and setting up the router. All right, now this will probably start to make sense. You can see I made this rolling assembly mechanism as well as an assembly, right? And I can put it in place. It has this cover on one side. We'll remove that cover with, there's a few screws holding that cover in place. And this had to be made, you know, pretty accurately, and I had to make sure everything was going to work, because once this thing is covered up, I wouldn't have access to it, because these skins are going to go over the top of that. These skins are designed to look like layers of Baltic birch, right? You see how the magnet is attracted to that magnet within the aluminum bar, and I'll be using a much larger magnet to activate the deadbolt. All right, so this is how I made the panels. I just made a jig. That brown is like a Formica, so the glue wouldn't stick to it, and everything's nice and square. I can put all these strips on edge, clamp them together, glue it all up, and then lay them out right? So all the edges are glued, edge glued. Throw these wedges in place. That lines everything up. Add a couple of clamps and some weight so they don't buckle in the middle, right? It worked pretty well. Tapped everything down to get everything nice and flush. Yeah, I love it.
All right. Let's see how this came out. It's going to be kind of different, but different is good, yeah. So you can see this wedge in action. It just lines up all my pieces, and then I simply knock it loose there, and check it out. That's so awesome. It's about 1/4 inch thick, strips of plywood, 3/4 thick, thick Baltic birch, and all glued together. And I'll make about 12 of these sub-assemblies, and then these will get glued onto the door, onto the torsion box. So it's like a 1/4 inch plywood veneer. That's so fun. I've got almost all my plywood panels made, and then this piece of maple here, it will border the plywood to clean up that edge.
So once I had all my panels glued up, and incidentally, I marked the time on my panels, so I know exactly where my time frames are. I just ran them through my drum sander with about an 80 grit belt, I think on both heads, cleaned them up nice and smooth.
Discovered something kind of cool. Anyway, I plan on putting these metal, they're 1/8 inch by 1/2 inch steel bars, and I plan on screwing this to the door, and then I'm going to cover that with a strip of plywood, and this will all be flush. So I'll have metal embedded in this door, and I can put magnets on there to hold notes and projects that I'm working on. So what I did on my last door, it was a metal door, and it was very effective. But anyway, it might be kind of dorky, I don't know, but very effective. So kind of worked out cool because, I don't know if you can see, but there's horizontal strips in this torsion box, and this spacing ended up perfect with these metal rods that I'll be attaching. Kind of a coinkydink, but it worked out. So I've got all these panels taped on the edge, and the reason I'm doing that is I'm going to use a woodworking glue on the perimeter to glue these panels down. And I've put tape here because what I'll do is I'll use contact cement on the rest of this, peel this off, put the wood glue around the perimeter, and then with contact cement I'll just put those down. The pressure will hold them. It's an industrial heavy-duty contact cement that we use at work, and then the rigid glue around the perimeter I'll be able to clamp it, and I'll get a really nice rigid bond when it's done. And so I'm basically utilizing two different types of glues to accomplish the task. Contact cement is all this red. I've got yellow glue on the perimeter, and I'm also edge gluing the edges of the Baltic.
I assumed that doing it this method would be easier than creating a large sheet or panel and trying to put that into a vacuum bag. And I believe I used Type Bond 1 around the perimeter. I know I'll get asked. It's the more rigid of the glues.
This might show it better. So I've got my pocket knife right there. I've got one side clamped over there. You can see that gap right there. It'll start to tighten because it's not quite making contact with the cement there on this side. So you can see that get nice and tight. Start getting glue squeeze all the way down. And then what I'm doing here is I double check, make sure that it's staying parallel to the top of the door. Got 29 and 5/16 on that side, 29 and about 5/16 on that side. So yeah, looking good. Okay, that was a mad dash to get all that done. Sometimes I wonder
Man, I've got no business filming while I'm doing this because anytime you're gluing, it's already a panic. So anyway, I flipped the door upside down. I had a sheet underneath sitting on this aluminum right here. And so that's nice and flat. That bottom piece of particle board acts as a cowl. And then I put these other wood cowls on top to distribute pressure all the way around the perimeter. So that should glue up nice and strong. And then we'll do the other side.